Welcome back to Boomer's Playground, and today we're going to be going over section 213, loops, while and for. So we often need to repeat stuff in code, and you'll often hear of a term called dry, which is just like the word DRY, and what it really means is don't repeat yourself. So if you ever find yourself writing the same code multiple times, you're going to want to stop and you're going to want to think, okay, how can I break this out and not have to type this every single time I want to use it? Functions are usually more common. We'll go over those in the next couple of videos, but for now we'll just be going over loops, which just lets us do something X amount of times over and over and over again. So here you'll see the for of and the for in loops. These are newer. These are probably going to be the ones you'll use the most, but we'll get into those in a further section. So the while loop has the following syntax. So you just have a while statement, and then you have some condition, and as long as this condition is true, whatever's in this block will run until this condition is no longer true. That's what it's saying there. So here you'll see we're setting I equal to 0. We're saying while I is less than 3, alert I, and then we're going to increment I by 1. So if you guys remember from the operand section earlier, this is super important. If you don't have this I++, this number, this I value, which is set to 0, will never change. This condition will always be true, and you will create what's called an infinite loop, and your browser will crash and or possibly your computer will crash. So it's very, very important that you make sure to always have either an incrementer or a decrementer to the thing. I really don't see while loops used a whole lot, probably for that reason, but they're still good to know. A single execution of the loop is called an iteration. Blah, blah, blah. If the I++ was missing, the loop would repeat in theory forever. So kind of what I was explaining, you need that there, or we would freeze the browser and or computer. So for instance, a shorter way, we'll start up here. An expression or variable can be a loop condition, not just comparisons. The condition is evaluated and converted to a Boolean by the while statement. So here we're just saying while I is a truthy value. And so we're starting at 3. We come in here, we say, hey, is 3 truthy? It is. Alert it. Subtract 1. That makes it 2. 2 is truthy. Alert it. Subtract 1. That's now 1. 1 is truthy. Alert it. Subtract 1. That's now 0. 0 is falsy. So this while loop will break out and won't run anymore. Curly braces are not required, but again, like I've said in a couple other videos, write your code for readability, not for terseness or shortness. The way browsers work now, so ridiculously fast that little things like that are no longer beneficial. And when you get to a framework, which almost everybody who's watching this will, they get minified anyway, so you could make a 10-word variable name and it's going to get broken down into A, B, just like single letters by the Babel or Webpack or whatever your framework uses. So the do while loop is very similar to the while loop, except this guarantees that this will always run at least once. So up here in the while loop, let's say we set I equal to 0 here. This while loop would never run because we would get, so I is equal to 0. Is I a truthy value? It's not. Okay, so just don't run the code. So the do while always runs once. So it says do, it runs the code one time, and then it checks if it should run it again with the same exact while check, and then whether that's truthy or falsy. So just like the one above, we set I equal to 0. We say do, we alert I, which is 0. We add 1, so I is now 1. and then we check the while. Is 1 less than 3? It is. So we do this again. So we alert 1, we add 1. I is now 2. 2 is less than 3. That's true. So we run it again. We get 2. We add 1 to 2. That's 3. Then we check the while again. Is 3 less than 3? It's not. So we no longer loop through this do while loop. This form of syntax should only be used when you want the body of the loop to execute at least once regardless. So kind of what I was just explaining about. This one's more beneficial. So the for loop is something you will use a lot. Like it showed at the top, you're going to use this for in, for of a whole lot more, but this is still good to know because sometimes you just want to, or it's just easier sometimes to use a for loop. So here, to write a for loop, we have 3 things. So we have the for statement, then we have our parens, and then we have 3 things. So here we have our initializer, or our begin, or whatever. Yeah, our begin. And so this is just saying, okay, let I equal 1. This happens the first time, and then I is just whatever I is. Then the second one is the check. And so this is like, hey, do I keep going? And then the third is an incrementer or decrementer. They call it a step. So one thing that's really important is this runs here the first time. So we get I equals 0. Then we do the check. Then we run the body of the code. And then after the body of the code runs, then we jump up to the step and we add or decrement. So it doesn't go like bam, 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 then code. We actually do the first one. We do our check, run the code, and then we increment, and then all we do is the check and the increment again. So in this instance, I is 0. So is 0 less than 3? It is. So we come down here and we alert 0. Then we jump up to our step. We add 1. Then we check again. Is 1 less than 3? It is. So then we come to the body. We alert 1. Then we jump to our step. We add 1, which now makes I 2. Then we check again. Is 2 less than 3? It is. So we run the body of the code again. We get 2. Then we jump to our step. And then we do 2 plus 1 is 3. And then we do our check again and we say, is 3 less than 3? It's not. So our for loop is finished. So I really just want to point that out because it's, it doesn't run, 1, 2, 3, then the code. It does 1, then 2, then the code, then the step. So, and this is something to just play around in the console with. That's something that I always encourage. That's why I always have, the console open, because then you can just kind of mess around and you can test stuff out. All right. So the begin executes once, like I said, just initially, and then we just kind of keep track of it along the way. Then it iterates after each condition, test, body, and step are executed. So pretty much what I was just explaining to you. It does the check, runs the body, then does the step. Inline variable declaration is just showing that you can do it right here. This let I is only available in the scope of this for loop. You can do it like this. I don't suggest this. Just do it this way. This does work, but just don't do it. Do it this way. So here we can skip parts. So here you'll see we haven't actually created what the first one is, but we did do it up here. So it still knows what I is. I is just available to things other than just this for loop. And you can remove the step part as well and do it in there. And you can just do them all, which this creates a infinite loop. Don't do any of these. Just write it all out each time. These are good to know that you can not do them, but just always use them. So breaking the loop can be important. This break is used far less now, mainly because there are a lot of built-in methods where if you have a situation where you want to break out of a loop, there's probably a built-in JavaScript method that will work better than using a break. But it's still good to know. So the loop exits when the condition is false, so that's that middle part here. Whenever this is whenever this part's false, that's when the loop stops. But we can force it to exit at any time using the break directive. So below, it asks the user for a series of numbers, breaking when no number is entered. So we have let sum equal 0. We have while true. So this is actually creating an infinite loop because true never changes. So this will just always be true, and it will just run forever, 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 which is kind of what they wanted to do. Here we're setting the variable of value equal to the prompt, whatever you type into the prompt. You'll notice we have this plus sign right here. That's turning this prompt into a number, because if you guys remember, prompt returns a string. And so this is just shorthand for, turn this into a number. You could also wrap this in parse int or number. And then if we get a falsy value, which would be 0, or if we hit cancel, or if we didn't put anything in the input, it would break out, and then this would stop running. So let's check that out real quick. And all right. So we're going to put 10. All right, so 10 was an actual number, so this ran, we came into here, it prompted us, we gave it 10, value is now 10. It's saying if value is false, which 10 is not a false value, so sum is going to be 0 plus 10. All right, so we got 10 there, so let's do 20. All right, so now we did the same thing kind of, because this was true, this ran again, it asked us for a number, we put in 20. Is value false? It's not. 20 is a truthy number, so this doesn't get run. Then we come down here, and sum, which is now 10, gets 20 added to it, so now sum should be 30. And so now if we hit cancel, cancel will give us null or undefined to this value. And when we come down here and it checks if value is a falsy value, which null or undefined is, it's going to break, and this loop will finally stop. And then you'll see we got 30 because the first number we typed in was 10, and the second number we typed in was 20. The break directive is activated at the line that we just showed, blah, blah, blah. Yeah, you guys can read that. That's pretty straightforward. We can also do, we can use a continue. And so this is kind of similar to break, except it doesn't stop the whole loop. It just stops that current iteration. It just says, hey, skip this, move on. And so what we'll see here is, I'm just going to go to console.log again. All right, so we have just a basic for loop here. So we're setting our I equal to 0. While it's less than 10, keep going, and then after each iteration, add 1 to it. And so what you'll see here is if I divided by 2 equals 0, and so this is actually the modulo, which I don't know if you guys remember from the operand video. What that does is that gives us the remainder of a division problem. So we're saying if the number divided by 2 equals 0, which means it's an even value, so you'll see this a lot. If it's even, just skip it. Don't worry about it. So what we should see are just odd numbers. So 0 comes in, 0 divided by 2, the remainder is 0. So we skip it with this continue. And we could even do the same thing, but for the odds, right? So if we did 1, that means it's an odd number. And so now we're just going to get nothing but evens. So continue doesn't break the whole loop. It just says, hey, don't worry about this iteration. Move on to the next one. So here, blah, blah, blah. Yep, and we could have even done this because remember, 0 is a falsy value, 1's a truthy value. So we didn't even really need the check. But, and even here it's just kind of showing how we don't have to nest things when we have that continue operator. No break continue to the right side of the question mark. So if you're going to use a ternary operator, you cannot use break or continue. Which again, in a ternary you wouldn't want to anyways because you're not really looping over anything. It's a one-time thing, so it makes sense why you couldn't use that or why you shouldn't use that, but I guess they're just letting us know. Also, labels are interesting. This is another one of those things that it's good to know, but you're probably not going to use it a whole lot unless you're working on like an old legacy code base that, you know, is using like older code. But so for instance, when you have nested loops, if you break out of the inner loop, it only breaks out of that loop. It doesn't break out of the whole thing. So what you can do is you can do a label like this. So now we have this outer loop has a label of outer. And then if we need to break out of the whole thing from the inner loop, we just use break and then the label name. So again, good to know. I've personally never seen this in production code. Mind you, I haven't seen all the production code in the world. But in the 5 or 6 years that I've been professionally developing, I've never seen it. So good to know. Probably not going to use it. You do need to have the outer. It can be on its own line. But it's got to be. It's either got to be right before the for, or it's actually got to be on the same line as the for loop. So that's all this is saying here. They don't allow you to jump anywhere. So here we created a label and it's trying to break to the label from outside of the loop. You can't do that. It must be inside the code block of the label that you're trying to break out of or continue out of. So here, yeah, we just covered 3 types of loops. The while condition, again, not super useful, not super used. I'm sure, you know, somebody will be in the comments telling me that they use it all the time. That's awesome. I'm not saying it's never used. I just don't see it a whole lot. Good to know you're probably not going to use it a lot. Same with the do while. This one's a little more interesting because it's like, hey, I need to run this code at least once, but I don't know if I'm ever going to want to run it again. So then you'll use the do while for that. And then we had our for loops, which that one you'll use quite a bit. There's actually that one that you still probably won't use a whole lot because there's so many built-in methods in JavaScript that we'll go over in the future that even the for loop is pretty not used a whole hell of a lot anymore. They showed us how to make an infinite loop, how to use continue, break continue. So that's all the stuff we learned today. So let's go over the tasks. All right, so what is the last value alerted by the code and why? All right, so I is equal to 3. So is 3 true? It is. So let's alert 3. Then we're going to subtract 1. So I is now 2. 2 is true. Alert 2. Subtract 1. 1 is true. Alert 1. Subtract 1. 0. 0 is not true. Break out of the loop. So the last thing that was alerted should be 1. And you'll see that it is. Also, something is with these, if there's any tasks for these sections, I really encourage you guys to try and go through them first. And then if you get them wrong, you get them wrong. It's fine. That's part of the job, part of learning. But try and do them first and then watch me go through them because sometimes I will break them down a little more than even these descriptions do if that's available. So try them first and then watch them with me after the fact. Which values does the while loop show? So for every loop, write down which value outputs and compare it to the solution. All right. So we have a prefix and a postfix. So let's see here. So we get let I equals 0. We're going to come in here. Is 0 less than 5? It is, but we're going to add 1 to it before we get into the block. So we're still checking against 1, or we're still checking against 0, but when it gets to here, it should be 1 because we're prefixing it. So this should show 1. This should show 1 through 5. Because this will be 0, but by the time it gets here, it'll be 1. So when this is 4, this will still be true, but then by the time it gets here, it'll be 5. So that's how we'll still get 5 in there. I think we should. One, two, three, 4. Okay, so I was wrong. So we did get 1 through 4. Okay, so that does work. So then this one should be 0. Oh, maybe. Oh, okay, so I was wrong about this. So this is actually adding it before we do the check. So this comes in as 0. We're adding 1, and then it's saying is 1 less than 5. Go, go, go. That's why we don't see 5, because when this is 4, we're still passing 4. But then when this is 4, we add the 1, which makes it 5, and then it's not truthy. So, but that's why we don't ever see 1, or we don't ever see 0, because we're always adding 1 to the number before we check it. And then this would be the opposite. This should actually be, this one should be 0 to 5, I think. Okay, so that's 1 to 5. So this will be, so here we're checking 0 is less than 5. It is, but we're adding 1 before we send it down here. So that's why we end up getting 5, because when this is 4, this is still true, but then we're adding 1 and then kicking it down to the console log. So here, go over this. This is going to explain it probably a little better than I did. The first value is I equals 1 because plus plus increments I, then returns the new value. Whereas down here, the postfix increments I and then returns the old value. So that's why we were getting those different numbers. So which values get shown? Yes, this one you guys will probably have questions on. Leave them in the comment section. This is something you're probably... This is another one of those, like, it's good to know. Definitely is, but, like, you'll never write that. All right, so here, which values get shown by the for loop? So here, we got 4, pretty much the same thing, but in a for loop. So this will show 0 through 4. This will show 0 through 4. The fact that we're postfixing or prefixing doesn't matter, because if you guys remember, we do the check, we do this check here, then we run the code, then we run the step. So this isn't going to change anything. These will both be 0 through 4. They can be, 0 to 4 for both of them. Output even numbers in a loop, so 2 to 10. So for here, we'll do let I equals 0 or 2, while I is less than or equal to 10. I plus plus. And so here, what we can do is we know that we want to do even numbers only. So we can do that little trick where we can do if I modulo 2 equals 0, which that means it's an even number. We can console log I, and then this should throw us 2 through 10. So one of the key parts here is this greater than or equals to. If we were to do just greater than and we did 10, we wouldn't get the number 10, because when I was 10 is 10 less than 10. That's a false, so this loop would stop. So this is one way to do it. There's another cool way to do it that we could do. So we'll do I equals 10, and then you can actually, your step, so the step here at the end, you can actually increase, decrease, you can multiply, you can divide by, you can do almost any mathematical operation in that step. They just haven't shown us this yet. So this would be another way for us to do it. Instead of us having to check if it's an even number, we can just add by 2 and we'll know that we continue to get 2 through 10. So let's see what they did. Yeah, so they did the first one, probably because they haven't shown us the fact that we can add, you can add by more than just 1. Yeah. Replace 4 with while. All right, so let's grab this guy. And so we have that for loop. And so let's do let I equals 0. And then we can do while I is less than 3. We can console log. I, and then again, let's remember we need to increment this I number, or this would become a infinite loop and we would crash the browser. So here we still get 0 to 2. Let's see what they showed here. Okay, yep, so pretty much that exact same thing. Here it wants us to repeat until the input is correct. So write a loop that prompts for a number greater than 100. If the visitor enters any other number, ask them to do it again. It must ask until they either enter a number bigger than 100 or cancel or enter an empty line. All right, so here we can just do we'll do while true, and now this is creating an infinite loop, so let's keep that in mind. And we'll do let value, we'll do plus prompt, and again that plus is just turning it into a number, because if you guys remember, prompt gives us a string no matter what we type in there. And then here what we can do is we can just check if values greater than 100 or not value. And actually we can just we'll just keep it all in one line. So what we're doing here is we're just checking, hey, if you give me a number that's greater than 100, break out of this loop. Or if you give me a falsy value, which would be if we hit cancel or if we didn't put anything in there, then that would break. So we can do 10, 40, 99, 101, and then we break out. And then we do 12, 14, whatever. And then if I just hit enter, we break out as well. And then if we hit cancel, we break out as well. So that is handling all of our edge cases. And okay, cool. So this one did the do while, which is kind of neat. Both work perfectly fine. I actually spent a little bit of time on this one. I'm not going to go over this task. I think this is an awful task for somebody who's just learning to program. This is assuming you have pretty good math logic, and just the logic needed to accomplish this just seems out of place for this level of learner. So I am not going to go over this one. If you are skilled with math and logic, I encourage you to try it, but I'm not going to waste my time. I'm not going to waste your time, because I just don't think I'm going to do this task any justice, and I don't think it's going to help you guys out at all. So I am just going to ignore that one. So that's the section on loops, while, do while, and for loops. I hope you guys learned something. If you guys have any questions, comments, or concerns, leave them in the comment section below. Discord server link is in the description. Like, share, and subscribe. And I'll see you guys in the next one.